Welcome back to Geometry with Mr. G, guys. I hope you had a great Christmas break. Here we are back at it, second semester. Let's do this. This is our first video notes for the semester, and we're talking about special line segments. Now, this is lesson 6.1. We're talking about special line segments that are in triangles. Our first one being, there's only 4 of them, so it won't be fat. It won't be long. Perpendicular bisector. Now, this is 2 words. So there's 2 things here. Perpendicular, we're talking about 90-degree angles. All right, you should be thinking 90-degree angles when you see the word perpendicular. And you should be thinking bisector, you should be thinking middle or cut in half, right? Remember that word? Middle or cut in half. Okay, so for a perpendicular bisector, what you need to know is that it always starts at the midpoint. Okay, always starts at the midpoint. And it is, you already know this, right? Perpendicular to the side it came from. So you're probably thinking, what does this all mean? Watch how I'll do this. I'm gonna pick a side, right? It doesn't matter which side. You can pick this side. You could pick this side. You could pick this side. You could pick this side. It really doesn't matter. Okay, I'm gonna pick the bottom side here, and you start at the midpoint. So you find the midpoint. Midpoint, you know, somewhere here in the middle. That looks like it's in the middle, and then you draw a line that is perpendicular. So you're just gonna go straight up. And that is perpendicular, creates a 90-degree angle, right? Also, since this is the midpoint, you know that this piece, right, is congruent to this piece here. So I can put my hash marks there showing that that is a midpoint. And that is an example of a perpendicular bisector. That's the first one. 3 more to go. Angle bisector is the next one we'll talk about. Of course, you know what angle is, right? And again, bisector, thinking cut in half, right? Cut in half. So we've got angle bisectors. Well, this one's easy to remember. They start at the angle. They start at an angle, or vertex, whatever you want to call it. Same thing. They start at an angle. They start at a vertex, and of course they bisect the angle. Cuts in half. Okay. So for this one, I'm going to do. I'm actually going to use this angle here. I'm going to use this one. Now, you could use any of the 3 vertices or any of the 3 angles, but I'm going to choose this one. And it'll look something, I don't know, something like this. It's probably not perfect, but close enough. We're going to put our little arcs in here, indicating that those angles are congruent. Because if this is an angle, if it's an angle bisector, right, and it bisects the angle, it's cutting the angle in half. So, you know, those 2 angles must be congruent. So, that's why I put those 2 arcs in there. All right, that's angle bisector. Let's look at median. So for median, we've got, when you see this word, you should be thinking middle, right, midpoint, all kinds of things, right? Starts at the, again, I'd like to start at the midpoint here. And it goes to the opposite angle or vertex. Opposite angle or vertex, right? Same thing. So for example, let's say I start with, I'm going to rotate it like this, make it easy. I'm going to use this side here. So I'm using this side right here. So I'm going to find the midpoint. There's your midpoint. And remember, to signify that this is a midpoint, put a hash mark. And then our notes say that it starts at the midpoint and it goes to the opposite angle. Well, the opposite angle, right, is going to be the angle that's across from it. So the angle across from it, I'm going to get rid of this arrow. Angle across from this side would be this angle here, right? The one that's opposite of that side. So you start here, you draw a line, going to this vertex. And there it is. That is called a median. So there is the 3rd one done. I'm going to put my page back to normal. Let's go to the 4th one. I'm rotating this to show you that you can draw these lines from any of the 3 sides or 3 angles, right, depending on what we're working with here. I'm just trying to show you different views. So let's do the last one here, altitude. Now, for altitude, you should be thinking, another word for altitude is height. So straight up and down, right? Straight up and down. Starts at an angle. Again, angle or a vertex, whatever you're calling it, whatever your teachers are calling it. And it's perpendicular to the opposite side. So when you think of height, also should be thinking 90-degree angle, okay? 90-degree angle. So, for example, we're going to start at, at a vertex or an angle. Now, again, I could start here, I could start here, I could start here. It doesn't matter, right? There's 3 angles, 3 vertices. So there's going to be 3 altitudes we can draw. I'm just going to draw one of them. I'm going to draw the one at the top there. That's going to look something like this. I'm going to just start this vertex. I'm going to go straight down to this bottom line because I want it to be perpendicular. So I'm going to create this 90-degree angle here. And that's it. That is an altitude. So let's kind of review what we just talked about by doing some matching here. All right, we've got match the name of the special line segment to the correct picture. So answer choice A says perpendicular bisector. Right, and this is 2 words, so we should be thinking 90-degree angle, and we should be thinking midpoint. Okay, so when I think midpoint, I'm thinking, okay, I should see hash marks. So you know it's either going to be 2 or 3, because 2 and 3 have hash marks on them. But then also, when you see perpendicular, you should be thinking right angle. And this is the only one that has hash marks, and it has the right angle. So I know that this has to be my perpendicular bisector. Awesome. Next one's answer choice B, or answer B here, says angle bisector. So again, we're talking about an angle, right? So we should have something within our angles. And we're talking about a bisector, right? Bisector. So in this case, again, like cut in half, right? Cut in half here. So we're cutting an angle in half is what we're doing. Well, the only picture that has any markings in an angle would be this one here, right? See how the 2 arcs, we got 1, 2, 1, 2, right? So that's your angle bisector. So this is B. And we got median. Remember, when you think of median, you should be thinking of middle or midpoint again, right? Midpoint's fine. Think middle, midpoint. So when I think of middle or think of midpoint, it's just the hash marks, right? And this is the only other side or the only other picture or triangle where I see hash marks. So this is my median. It goes to the midpoint, which means this has to be my altitude. And again, altitude, you should be thinking 90-degree angle, which we have 90-degree angles here, right? You can see the box. This line here is perpendicular to this bottom side, so that is an altitude. And there you have it. The first page is done. Let's go to the back page. So we're on the back page now, and 5 through 8 are just some application problems for where we're going to see these in problems. Where's the math come in for all this? And it's actually very simple, very easy stuff. Most of the stuff you should already know how to do. It's just applying those words. So if number 5, it says, in triangle PQR, QS is a median. So I'm going to actually go ahead and box in that word. It's a keyword, right? And we're talking about QS. So QS is a median, right? Well, if QS is a median, then I know S is the midpoint of this side down here, right? Because remember, the median goes to the midpoint. Median, you're thinking middle. Thinking midpoint. So then I know that this piece, P to S, has to be congruent to SR. So those parts are congruent. Then the problem continues to tell you that PS is 4x minus 2, and SR is 2x plus 4. And it says find the value of x. Well, easy. We know that these parts, right? This is part 1, this is part 2. We know these parts are congruent. They're equal, right? That's what the hash marks tell us. And we know that because S is a midpoint, but the word median, all that stuff. So this is just review. We know how to do part equals part already. We've got 4x minus 2 equals 2x plus 4. Let's draw our line. Let's do our math. I'm going to do minus 2x first. Leaves us with 2x minus 2 equals 4. I'm going to go ahead and do plus 2 now. Leaves us with 2x equals 6. And then we're going to divide by 2 on both sides. We're going to get x equals 3. Now the question asks us to solve for x, so we are done with number 5 at that point. Okay, so now on to number 6. We've got AC is an altitude. I'm going to box that in. It's a key word again, right? We're talking about AC, right? AC is the altitude. When you see altitude, you should be thinking 90-degree angle. And it's the altitude of the triangle ABD. Find the measure of angle 1. So we're looking for this angle here. So, okay, well, that's not too hard. We know that A to C is an altitudes, which means we have 90-degree angles, right? 90-degree angles. Well, hey, if we look at just this triangle here, right, you see the one I'm coloring it right here, tracing? If you look at just this triangle, you know 2 of the angles. You know 50 and you know 90, right? You know 50, you know 90. So let's find this third angle here. Let's find this missing angle. So we can do 50 plus 90. which is 140. We know that all the angles in a triangle must add up to 180, so 180 minus 140 will give us 40. So this angle here is 40 degrees. Well, you now also should know that this 40-degree angle in angle 1, look what I'm tracing here in blue, that is a linear pair, right? We already know this. This is all review, pretty much. That's a linear pair, and you know a linear pair must add up to 180. So if we do 180 minus 40, that'll give us the measure of angle 1, which is 140. So the measure of angle 1 equals 140 degrees. All right, cool. We're almost done here. So number 7 says EG is an angle bisector. That's our key word here. And remember, EG is the angle bisector. That's important, right? This is our angle bisector, which means we're cutting this angle here into 2 equal parts, right? 2 equal parts. So I'm going to put my arcs in each of those angles, showing that they're both equal and they're both congruent. And then it says find the measure of angle F. So we're looking for this angle here, right? This is the angle we're looking for. So what can we do here? Well, the first thing I notice is we've got, again, you should notice what this is. This is a linear pair. So how do I find this missing angle here? Well, a linear pair adds up to 180. So if I do 180 minus 65, we get 115. So this angle is actually 115 degrees right there. Well, now look at this triangle I have right here. See the one I'm tracing in yellow? This side here on the left side? Well, now we know 2 of the angles in that triangle. So let's find the third angle of that triangle. You already know how to do this. So 115 plus 35, which is 150. We know that all 3 angles must add up to 180 in a triangle. So 180 minus 150 equals 30. So this angle up here is 30 degrees, right? Well, guess what? If that angle is 30 degrees, then this angle here must also be 30 degrees. They're congruent, they're equal, right? That's what it means to be an angle bisector. So now we can look at this triangle here on the right, and we can find angle F because we know 2 of the angles in that triangle. We know 30, we know 65, so let's find the missing angle. We've got 65 plus 30, which is 95. All 3 angles have to add up to 180, so 180 minus 95 is 85. So the measure of angle F equals 85 degrees. And we're on the last one. This is number 8. It says that LM is a perpendicular bisector, right? This one it's the longest one, has 2 words. The most is happening on this one, right? And LM is our perpendicular bisector. So if I look at LM, it's this line here, right? That means L has to be a midpoint. That's what bisector. You should be thinking of bisector in the middle, cut in half. That, all those words. So I can actually put a hash mark here and a hash mark here, showing that those 2 parts are congruent. And then remember, so again, this means middle, right? Middle here. And then perpendicular means 90-degree angle. So I could put right angles here and a right angle here, showing those are both 90-degree angles. It says that L to N is 12y minus 7. And L to P is 13 plus 11y. And then it also says the measure of angle NLM. It's been a while since we had to read angles, so let's make sure we know how to do that. N to L, L to M, right? See this blue line here, or the blue 2 lines I'm tracing here in blue? So this is the angle we're talking about right here, right? This angle right here. It says that it is 5x minus 5 degrees, okay? Find the values of x and y. We're looking for x and y. Well, this is easy. Let's do y first. We already know how to do that, right? This is a part. This is a part. They each have a single hash mark, so they're congruent. They're equal. So part equals part again, right? Part equals part. So we're going to get 12y minus 7 equals 13 plus 11y. Let's go ahead and draw our line. And I'll go ahead and do minus 11y first on both sides. That leaves us with y minus 7 equals 13. And then I'm going to go ahead and add 7 to both sides. We're going to get y equals 20. So there's y. Now let's find x. Now x, it's super easy. You just got to think about it a little bit more. We are told that angle, or we're looking for x, we have 5x minus 5, right, equals Well, guys, we know that this angle here, right, this angle here at L and LM, remember, this is a perpendicular bisector, so this has to be 90 degrees. Remember that box we put there earlier? So 5x minus 5, 5x minus 5, right, we're here, has to equal 90, right? It has to equal 90 degrees. So there's our formula. Let's go ahead and solve for x. Draw my line. We're going to do plus 5 first. So we're going to get 5x equals 95. And then we're going to go ahead and divide both sides by 5. And we're going to get x equals 19. And there it is. Come see us if you have any questions.